Hi guys, in this video we'll be discussing the problem from starters 72, and the problem's name is apples and oranges, and the problem states that there's a certain person R and he went to a programming contest to distribute apples and oranges to the contestants. He has n apples and m oranges which he needs to distribute equally amongst all the contestants. Find the maximum number of contestants such that everyone gets an equal number of apples and everyone gets an equal number of oranges as well. Note that every fruit with this person must be distributed. There cannot be any leftovers. So he can't waste any fruits or cannot keep any leftovers. He have to distribute every single piece of fruit he has with him. For example, 2 apples and 4 oranges can be distributed equally to a maximum of 2 people, and where each one would receive 1 apple and 2 oranges. However, 2 apples and 5 oranges can only be distributed to a single contestant, because we might be able to distribute 2 apples amongst 2 people and both of them would get a single apple, but we won't be able to distribute 5 oranges equally amongst 2 people. Hence the greatest number where we can distribute them equally would be 1. So for one contestant we'll give him 2 apples and 5 oranges, and the input format is that they'll be giving us the number of test cases first, followed by the integers n and m, that is the number of apples and number of oranges. So with that, let's get started. So this is a pretty easy problem, I'll say. It just relies on the fact that we have to calculate the GCD. Now how do we get to the conclusion that a GCD is required for this particular problem? What we can say is that if we have two numbers a and b, so the GCD basically is the biggest number that divides both a and b. So let's say we had 20 and 10. So the divisors for 20 and 10 would be 1, obviously, 2, 4, 5 and 10. So now all of them actually divide both 10 and 20, but the biggest common divisor, or the greatest common divisor, also known as the GCD, is 10 over here. If I have 10, then I can say 10 divides the first element, that is 20, and 10 obviously divides 10 as well. So that would mean I can distribute the things from A and B to 10 people. Why is it so? Because since 10 divides A and 10 divides B, hence when I'll divide A by B, A by 10, I'll get some integer values. These won't be fractions because A is actually dividing A. Also, when I'll talk of B, I'll still be getting some integer values, right? So I can then distribute these integer values to 10 people in total, and that's how we go about it. So it's as easy as that. So for the code, we'll simply take the number of test cases as the input first. We'll go for all of the test cases. We'll ask for the inputs A and B. GCD is something you can actually implement on your own, but it's already built in C++, or I guess in this particular library. So you don't need to code this thing on your own, and you can simply use this particular function GCD a, b, and then try to run it. Let's see. Yeah, we have the correct answer. I can't submit it because I'm from a different division, but this code is definitely correct. You can try this out. That's it. If you have any doubts, let me know in the comment section below. Thanks a lot, guys.